A big thing that I've heard and seen a lot in regards to this class, and especially because it's new, and so I've been a part of a lot of like group discussions and workshops and things like that in regards to the fact that this is a relatively new class. And graphs of inverse functions has actually shown up a lot in a lot of the like practice problems for this class. So I would say that it's pretty important that you know how to do this. Because I think it's going to show up on the IB exam in some way, shape, or form. If I were a betting woman, which I'm not, I would bet that it's going to be on the exam. So how do we graph it? Well, if we know that xy lies on the graph of f, we know that then the flip of that, yx, must lie on the graph of f of -1, right? So if you go through for the original graph and find all your points, 1, 2, 3, 4, you just flip them, and then you plot your new points. And we know that then this graph is reflected over the line y equals x. So if I were to graph, like, just really quickly and show you what I mean by that, is if I have the line y equals x, and I were to plot the point 1, 2, and then the point 2, 1, notice that they are a reflection over this line, right? If you were to mirror that image, it would mirror across that line. I could also do that with 3, 4. This is very much kind of like a guesstimate kind of thing, but you're getting the general idea. 3, 4 and 4, 3 are also reflected across that line. Now, if you have a point that has the same x and y value, like for instance up above we had 5, 5, it is its own inverse point, and it happens to also lie on this mirror line that we are reflecting across. So that's why 5, 5 kind of seemed like a weird repetitive thing. It's because the fact that that was the point that happened to be on the mirror, and so it just stays there in regards to the reflection across that line. We're going to graph this guy together today, and then we're going to do this in class the next time I see you. So we are going to graph the original function, which is cubic, and then we want to graph its inverse in the same plane. So this is the first time we're talking about an inverse when it's not linear, but it's totally fine because we just know that it's the same as the original function, just everything is flipped around. So I'm first going to graph this equation. If you don't know how to graph anything ever, making a table of values is the way to go about that. So let's say I wanted to plug in -2, -1, 0, 1, 2 for the original. I would make this into a table, but I actually really want to show you it with points, and so I'm not, but it's kind of the same idea as a table of like, okay, now I'm plugging in -2. So plugging in -2 for this function becomes -8 plus 3, which is -5. -1 becomes -1 plus 3, which is 2. 0 has 3. 1 goes to 4. And 2 goes to 11. So now you have a set of points you could graph, right? So -2, -5, -1, -2. Oh, sorry, -1, +2. 0, 3, 1, 4, and then 2, 11. Once you have these set of points, you can kind of get a general idea. Notice if I didn't have 2 or -2, it would look like a line, but it's not. And so that's where your understanding of how graphs of this nature should look. A graph of a cubic has like little dancy arms that go up or down or however you'd like in those different directions. So connecting those dots in the most cubic way you know how, it looks something like this. So it's important to know the behaviors of graphs in order to plot them appropriately. Okay, so that's the original function. That is g of x in this case. So we want to find g to the -1 of x, in other words, the inverse of this function. And what I'm going to do is I'm literally first going to make a list of all of my flipped points because I think that that makes sense. It just helps me to kind of piece things together because reflections, when it's not linear, gets a little tricky and a little hard. And so I'm going to first do flip all of those, -5, -2, 2, -1, 3, 0, 4, 1, and then I ran out of space. Here, let's do this instead. 11, 2, and then this is G. Okay. So I'm going to plot -5, -2, 2, -1, 3, 0, 4, 1, and then 11, 2. And then I want to I might like flip the page and look at it like this way because a lot of us, we feel trained on viewing it in this manner. But notice that you've still got the dancy arms, it's just now in a horizontal way. And so we connect the dots in the most cubic way we know how, which is rather dance and movement like. And that results in your inverse, which is pretty cool. I think the relationship and the image of a graph and its inverse can be a really beautiful design. Something cool to maybe explore in art classes, if that's something that you're interested in. So I'm going to go ahead and plot the graph of the line y equals x. And I want to show you a mistake that I made because I didn't notice it until just now. So this is the line y equals x. It's a minimal mistake, but I know that where the two graphs intersect of the original and its inverse will intersect always at this line of reflection. And so that's something to keep in mind, is that if you always draw in this line of reflection, it kind of can help you out in finding those reflected points, right? If you're isolating them and trying to imagine them being reflected across this line. It also helps you when you're connecting these dots that this should have been crossing like across here, or maybe this, I think it's probably that this line probably should have been extended out just a little bit more, something more like that, right? Minimal mistake, but it's like a nice thing to know to kind of help guide your sketching process as you're graphing original functions and their inverses. So this is everything that we need to know about inverse functions. Again, we're going to do this in class the next time I see you. As long as you remember that everything is flipped, I think you're going to be on a good path. And so if you always just need to flip things to talk about it in the original function in order to understand what we mean in regards to the inverse function, that is your main goal. Just everything being flipped. Inputs become outputs, outputs become inputs, x becomes y, y becomes x. It all is just flipped. Good job.